How's it going, ladies and gentlemen? Mashani here again. Going to talk about formal charge. What is it and why does it matter? Why are we bothering to learn about this stuff? Uh, why? All right, so why is basically, let's say you had these two structures. You're you're trying to draw a Lewis structure for CO2, and you can probably tell, like right off the bat, that you're probably like, that one's wrong, right? You might just intuitively know that, but why? Why is that not the right structure? Why is the first one usually what we draw? They both satisfy the octet rule, right? They all, like, carbon has 8 electrons, oxygen has 8, that oxygen has 8. They all, satisfy the octet rule. So which structure is the best? Which one are we going to draw? Which one actually exists? All right, enter formal charge. That's why we're going to learn about formal charge. It'll help us figure out which structure is more likely to exist. All right, so formal charge is the charge that atom would have if electrons were all shared equally in a molecule. So the more neutral each atom is, the more stable and the more likely that structure is to exist. Looking at, all these bonds, and we're going to say, all right, well, what would their formal charge be if they were sharing all these electrons equally? All right, so how do we go about calculating it? You'll see the basic formula will be formal charge equals the atomic valence electrons, so basically just how many valence electrons does it have normally, minus the assigned electrons. And you may be asking, what the heck is an assigned electron? Well, if we were to take a look at these structures, these electrons right here, they're assigned to that oxygen because they're unshared electrons. So right here we got 1, 2 assigned electrons. We got 2 more. We got 2 more up here. So this oxygen's looking like it has 6 unshared electrons. And well, what about this bond thing? What the heck? What's going on here? Got to remember that a bond is 2 shared electrons. Right? So we got oxygen and carbon sharing 2 electrons. So we're shared evenly. It's kind of like they each have 1. Right, so oxygen would get, like, this one be part of oxygen's, and then the other one would be part of carbon. Like, say you're getting pizza with a friend, right? And you're like, what kind of pizza you want? I don't know. I want pepperoni. You'd be like, well, I don't like pepperoni. I want, a plain one. You go, all right, well, we'll get 2 pies and we'll split them. I can have half of your pepperoni. You could have half of my cheese, and we'll all be happy. Right? So we're going to take all of the unshared electrons are assigned, and then half of the bonding electrons are also assigned to that atom. So an assigned electron is all the unshared electrons and half of the shared electrons, right? So if they're sharing 2 electrons here, half of that is 1, so it would get 1 of those electrons. So really, if we're looking at the equation, if we're talking about the math, you take the atomic valence electrons minus the assigned electrons, all right, which is really the same thing as the atomic valence electrons minus the unshared electrons and half the bonding electrons. Now, every bond is 2 electrons, right? So that's 1 bond. And for each bond, it's 1 assigned electron. So it's really the same thing as saying it's the valence electrons minus the unshared electrons and the number of bonds, right? Because for each bond, we get 1 of the electrons. So if we go back and we look at CO2, all right, well, let's look at the first oxygen over here. What is its formal charge? Well, how many valence electrons does oxygen have normally? It's got 6. All right, so minus, all right, well, how many unshared electrons does it have? It has 4 unshared electrons, so 4 and half of those guys. All right, 2 bonds, so there's 4 electrons. Half of that would be 2. So what do you get? 6 minus 4 and 2, and you get 0. I can't. Oh wait, watch this. I got an eraser. Erase. 0. Right. So what about the carbon? The carbon here, we got 4 valence electrons normally, minus it's got no unshared electrons, but it has 4 bonds. So it has 4 electrons to itself. Its formal charge is 0. And we take a look at the other oxygen. It's going to be the same thing as the first one, right? It's got 4 unshared electrons and 2 bonds. So it'll give you formal charge of 0. Now let's take a look at this one though, right? So first it starts with 6 valence electrons minus how many electrons does it have unshared? 6 plus half the bonding electrons, 1, gives you a charge of -1. So that oxygen would have a formal charge of -1. If you take a look at this carbon, it'll be again 4 minus unshared electrons would be 0 plus how many bonds does it make? 4, gives you 0. And then we take a look at that second oxygen over here. It starts with 6 valence electrons. It has 2 of its own, and it's making 3 bonds. So its formal charge would be +1. So which one is more likely? Well, you got to remember that we're looking for the lowest formal charges, most neutral. We want closest to 0. Like here, how they are all 0, that is awesome. Whereas over here, you got ones that are +1 and -1, and they're not all 0. Not so awesome. That's not what you want. All right. So which one's more likely? That one. All right. So I hope you found that helpful in formal charge, and I'll see you in class.